Hello friends, welcome to the online education. Paper number 502, Organic Chemistry and Spectroscopy. We have started unit number 2 and chapter number 2, synthetic drugs, dyes and sweetening agents or pigments. And we have completed drugs and dyes. Now, today we have started sweetening agents or pigments. Our first sweetening agent is saccharin. So, now we have learned about the synthesis and uses of the saccharin. Saccharin is a 500 to 550 times greater sweet than sugar. Saccharin is sweeter than sugar. How many times? 500 to 550 times sweeter than sugar. Now, it is synthesized by the first Aronson and Constantine Falber in 1879. This is the two scientists we have prepared the first time saccharin in 1879. Now, saccharin is sweeter than sugar, 500 to 550 times greater than sugar. Now, we have learned about the synthesis of saccharin. First method is saccharin from toluene. So, now we have learned about the saccharin from toluene. We have first checked the toluene, and toluene is reacted with the chlorosulfonic acid. This is the chlorosulfonic acid. Chlorosulfonic acid. Toluene is reacted with the chlorosulfonic acid in a cooling condition, 0 to 5 degrees Celsius temperature. In a cooling condition, chlorosulfonic acid and toluene reacted with in a temperature condition is 0 to 5 degrees Celsius. This is the cooling condition. And to produce a mixture of orthotoluene sulfonyl chloride and paratoluene sulfonyl chloride. This is the mixture of orthotoluene sulfonyl chloride and paratoluene sulfonyl chloride. Now, orthotoluene sulfonyl chloride is a liquid form and paratoluene sulfonyl chloride is the solid form. This is the mixture. And now we have separated them and we have used for a production of a saccharin, we have used the orthotoluene sulfonyl chloride. Now go ahead. Orthotoluene sulfonyl chloride is reacted with the ammonia molecule. This is the ammonia. And removed 1 mole of HCl and to produce a orthotoluene sulfonamide. This is our second intermediate product, and this is our first intermediate product. This is the mixture of orthotoluene sulfonyl chloride and paratoluene sulfonyl chloride. This is our first intermediate product. And orthotoluene sulfonamide, this is our second intermediate product from orthotoluene sulfonyl chloride. This is the liquid form. Reacted with the ammonia and removed 1 mole of HCl and to produce orthotoluene sulfonamide. Now, orthotoluene sulfonamide is reacted with the alkaline KMnO4. Alkaline KMnO4. KMnO4 means potassium permanganate. Potassium permanganate in alkaline condition and to produce our third intermediate product. This is the third intermediate product. Now this product is heating and 1 mole of H2O was removed and finally we have produced a final product, saccharin. This is the saccharin and this is the structure of saccharin. Structure of a saccharin, a phenyl ring is combined with the one carbonyl group, amine group and SO2. and this is the structure of a saccharin. So we have prepared a saccharin from toluene. We have prepared a saccharin from the toluene in a various type of reagent like chlorosulfonic acid and ammonia, alkaline CheMnO4, and finally to produce a saccharin. Now we have learned about the saccharin from ethanoic acid. Now we have learned about the second method of saccharin from ethanoic acid. Our first method is saccharin from toluene, and now our second method is saccharin from ethanoic acid. So this is the structure of ethanoic acid. Now we have taken the ethanoic acid in a condition and reacted with NaNO2. This is the sodium nitrite. Sodium nitrite. And also concentration H2SO4 in a cooling condition 0 to 5 degrees Celsius temperature, and we have produced a diazonium salt. First of all, we have taken the ethanoic acid and reacted with the sodium nitrite and concentration H2SO4 in a cooling condition 0 to 5 degrees Celsius temperature, and we have produced a diazonium salt. This is our the first intermediate product. Now this intermediate product is reacted with the liquid form of sulfur dioxide, liquid SO2, and in the presence of a copper catalyst, and to produce a 2-carboxy-benzene sulfonic acid or ortho-carboxy-benzene sulfonic acid. This is our second intermediate product, and name was 2-carboxy-benzene sulfonic acid or ortho-carboxy-benzene sulfonic acid. This is the carboxylic group and this is the sulfonic group, and it is called 2-carboxy-benzene sulfonic acid. This is our second intermediate product. Now this second intermediate product is reacted with the sodium hydroxide in an aqueous form, and this process is called chlorination. Cl2 in the presence of NaOH, and to produce a ortho-carboxy-benzene sulfonyl chloride or 2-carboxy-benzene sulfonyl chloride. This hydroxyl group was converted to the chloride group and to form ortho-carboxy-benzene sulfonyl chloride, or other name is 2-carboxy-benzene sulfonyl chloride. This is the structure of ortho-carboxy-benzene sulfonyl chloride, and this is our third intermediate product. Now this product is heated with the ammonia. And finally we have produced our final product saccharin, our sweetening agent saccharin. One carboxyl group, one amine group, and SO2, and finally we have produced the saccharin. So this method is from the ethanoic acid, saccharin from ethanoic acid. This is our second method, and our first method is saccharin from toluene. And now we have learned about the uses of saccharin. Saccharin is used in a place of sugar, like cold drinks, some sweetening sweets like gulab jamun and many others. And this is the saccharin which we will use in a place of sugar. So this is the synthesis and uses of saccharin. Now we have learned about our second sweetening agents, P-N-acyl urea. This is our second sweetening agent, P-N-acyl urea. Now we have learned about the synthesis of P-N-acyl urea. That is Para-nitrophenol. This is the structure of para-nitrophenol. Now we take the para-nitrophenol in the condition of aqueous NOH and reacted with the dimethyl sulfate. This is the dimethyl sulfate, and this process is called methylation because we will use the as a reagent dimethyl sulfate, so it is called methylation process. So para-nitrophenol is reacted with the dimethyl sulfate in presence of aqueous NaOH, sodium hydroxide, and we have produced a para-methoxy nitrobenzene. This is the structure of para-methoxy nitrobenzene. This is the methoxy group, and this is called para-methoxy nitrobenzene. Now this is our first intermediate product, para-methoxy nitrobenzene. Now para-methoxy nitrobenzene is reducted with the stannous or HCl. This is the metal stannous, and this is our hydrochloric acid, and this process is a reduction process, and we will produce a para-methoxy aniline. And this is the structure of para-methoxy aniline, amino group and methoxy group, para-methoxy aniline. And this is our second intermediate product. Now our second intermediate product is heated with the urea. This is the urea, and it is removed 1 mole of ammonia, and finally we have produced a P-N-acyl urea. This is the structure of P-N-acyl urea, methoxy group, and our urea was combined and 1 mole of ammonia is removed and urea was combined and formed the final product P-N-acyl urea. This is the P-N-acyl urea. So this is the synthesis of P-N-acyl urea. Now uses of the P-N-acyl urea. P-N-acyl urea and saccharin also similar uses because this is also sweeting agents like a saccharin, and it is also used as a sweeting agent in place of sugar. So this is the synthesis and uses of P-N-acyl urea and also synthesis and uses of the saccharin. Now we have learned about our third sweeting agents, dulcin. Now synthesis and uses of the dulcin. Dulcin synthesized by two methods, dulcin from para-ethoxy nitrobenzene and dulcin from phenacetin. Now we have learned about our first method, dulcin from para-ethoxy nitrobenzene. Now we have take the para-ethoxy nitrobenzene. This is the structure of para-ethoxy nitrobenzene. It is reducted with the stannous or HCl or ferrous with HCl. This is the two reducing agent, stannous or HCl and ferrous or HCl. Reduction with the stannous or HCl and ferrous with HCl. And we have produced our first intermediate product, para-ethoxy aniline. This is our first intermediate product, para-ethoxy aniline. So first we have taken the para-ethoxy nitrobenzene, reduced with the stannous with HCl or ferrous with HCl, and to produce the first intermediate product, para-ethoxy aniline. Now we have second reagent, urea. This is the urea. Para-ethoxy aniline reacted with the urea and 1 mole of ammonia was removed. This is the ammonia. 1 mole of ammonia was removed, and finally we have produced a dulcin. This is the structure of dulcin. Para-ethoxy group is combined with the phenyl ring, and our urea was combined and 1 mole of ammonia was removed and to produce a dulcin. This is the first method of production of dulcin, synthesized by the para-ethoxy nitrobenzene. Dulcin from para-ethoxy nitrobenzene. This is the first method. Now we have learned about our second method, dulcin from phenacetin. This is our second method. Now we have taken the phenacetin. This is the phenacetin, structure of phenacetin. Terethoxy group and also phenyl ring connected with the NHCOCH3. This is our acetophenone group. Now phenacetin is reacted in the hydrolysis process. This is the hydrolysis process, and to produce our first intermediate product. This is the acetophenone group COCH3 is converted into the carboxylic group, and to produce our first intermediate product. Now this product is reacted with the SOCl2 reagent and to produce our second intermediate product. Now this carboxylic group is converted into the COCl and produce our second intermediate product. This second intermediate product is reacted with the ammonia in the heating condition process, and finally we have produced a dulcin. This is the structure of dulcin, and we have produced a final product dulcin from phenacetin. So this is the second method of production of a dulcin from phenacetin. First method, para-ethoxynitrobenzene reagent, and second method is a reagent is a phenacetin. So this is the synthesis of dulcin. Now uses of the dulcin. Dulcin is used as a sweetening agent in place of sugar. Dulcin also used as a sweetening agent, like other two our sweetening agents like saccharin and P-N-isolurea, and our third sweetening agent is a dulcin, also used as a in place of sugar. So this is the synthesis and uses of the dulcin. So this is our third sweetening agent have completed. Now in this chapter we have studied about the drugs, dyes and sweetening agents. First of all, we have studied about the drug. Our first drug is ibuprofen. We have studied the synthesis and uses of the ibuprofen, and second drug is atenolol, synthesis and uses of atenolol we have studied, and finally our third drug is adrenaline, catecholamine or epinephrine. We have studied about the adrenaline synthesis and its uses. And then we have studied about the dyes. Our first dye is orange 2. We have studied about the synthesis and uses of the orange 2. And our second dye is chrysodine G. We have studied about the synthesis and uses of the chrysodine G. And our third dye product is oramine O. We have studied about the synthesis and uses of the oramine O. And finally today we have learned about the sweetening agent or pigments. Our first sweetening agent is saccharin. We have synthesis and uses of the saccharin and studied about the second sweetening agent is P-N-isolurea. And finally, our final sweetening agent is dulcin. We have synthesis and we have studied about the synthesis and uses of the dulcin. So, guys, this is our first chapter, synthesis of drugs, dyes and sweetening agents or pigment. And we have completed the first chapter of Unit 2, synthesis of drugs, dyes and pigments. This is the first unit of first chapter completed, paper number 502, organic chemistry and spectroscopy. We have completed this chapter, synthetic drugs, dyes and pigments. And this chapter are completed today, and now next time we have started a new chapter.